All right, folks. So let's look at 8.3.3 today. So what happens if you want to evaluate the sine or cosine of a sum? Is sine of a plus b equal to sine of a plus b, sine of b? Why or not? Today, you will write formulas for angle sums and differences with trigonometric functions. And for the record, it's not always true. Look at that. All I need is one example to prove or disprove something. So we need to figure out what are the rules because we're going to use them. Dun, 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 dun. All right, so we're going to work together on deriving these identities. There's a link to a resource page, and you can grab this from the presentation, and at least 3 colors to follow along with what I'm about to do. All right. So we have all these triangles. The most important triangle is this blue one. Because in this triangle, this angle down here is a plus b. Basically, what I want to do is try to figure out, since this is 1, what is this length? That would be cosine of a plus b. And then what is this length, which is sine of a plus b? And not only have I marked them on this little triangle is represented in this big diagram right there. So that I would recommend color coding. Highlight them with the same color so that you can see where everything is. Because I get lost, and I think it's helpful to list out the different things. As I said, this is sine of a plus b. This is cosine of a plus b. Our goal today is to try to figure out, how do I represent those lengths using this diagram? Let's see if we can find this length. And there it is. You see that? Because this length is 1, that angle is b, and this length is cosine of b. So this side should be this green value. That's sine of b, right? Because this is 1, that's angle b. So if I did sine of b, I would get this side over 1. So solving for it, I get sine of b equals this side. It all kind of follows from everything we've talked about so far. We should label it over there as well. All right, let's take that and do some more. So now the next thing I want to do is write one or more equations within the triangle and use it to solve for j and k. Where are j and k? Haha. Right there. So we have this other little reference triangle for triangle with the angle A in it. So we can start to try solving things. So I want to try to write an equation to solve for j and solve for k. Well, from angle A, I probably could write something with cosine and something with sine to solve for j and k. I get sine of a times cosine of b and cosine of a times cosine of b. So let's pump the brakes and go back to why it's that. Well, from angle A, let's say I did sine of A. Well, sine of A would equal j divided by cosine of B. And again, up here, I mentioned I wanted to solve for j. So if I multiply both sides by cosine of B, that's how I get sine of A times cosine of B, is this length right here, this value j. Well, for k, I could say cosine of A equals k divided by cosine of B. Again, solve for k and get k all by itself. I can multiply both sides by cosine of B. And that's how I get cosine of A, cosine of B. I'm labeling on the diagram, the bigger diagram as well, because we're going to use the bigger diagram later, and I like kind of keeping track of things this way. Just a moment. Hey, I'm back. Okay, so let me go back a step. Oh, that's right. So I don't know what this angle is, but I'm going to call it alpha. This is A, this is alpha, which means That angle is alpha. Now it's going to be helpful for us in the next thing we do. What I'd like to do now is write one or more equations within the triangle and use it to solve for P and Q. Where are P and Q? They're going to be up there. I guess you needed a fourth color. My bad. But there's P and Q. Well, how are we going to solve for them? We have a hypotenuse, but we don't have any angles. Or do we? There's an A that popped up in there. Let's pump the brakes and see how that happened. Well, over here, we see alpha and A. Alpha and A should add up to 90 degrees because that's 90. All three of these have to add up to 180. That's alpha. This angle right here is 90 degrees. So this angle has to be angle A. So I could, to write an equation for P and Q, I could use sine and cosine of angle A to write an equation for P and for Q. So for P, I could do sine of A equals P divided by sine of B, which would give me sine of A sine of B. For Q, again, to put it away so you're not distracted by that part, cosine of A equals Q divided by sine of B, which gives us sine of B cosine of A for Q and sine of A sine of B for P. Nice. All right, here's the ultimate moment of bringing it all together. So sine of A plus B, this tall blue one here, this should be made up of some combination of some segments that we identified, and that was the goal here. Well, it looks like sine of A plus B is made up of sine of A cosine of B, this pink one, plus this orange one here, sine of B cosine of A. Sweet. Cosine of A plus B. There's right down there, cosine of A plus B. Well, this pink one down here, which I don't think I ever, oh, it's labeled right there, cosine of A cosine of B. That is what we need, but it's too much. It'd be nice if we could subtract off this little piece. Luckily, that's a rectangle. It's the same value up here, sine of A sine of B. So we have cosine of A cosine of B, and we're subtracting sine of A sine of B. Wow. Boom. Here's how they'll show up in the math notes. There's the sum, the one we just did. The tangent, we're not going to derive, but basically if you just do sine divided by cosine and simplify it, it turns out to be that. We could also do difference identities. So coming back to this, these are the angle sum identities for sine and cosine. Meaning if I want to find out what sine of two angles added together, this is how I can split it up. And same thing for cosine. But what if they're subtracted? Well, subtracting is really just adding an opposite. So really you just do A plus negative B, and that's how these come about. Now they require a couple of the things from a couple identities from previous math notes box, but the big thing is just notice the symbols here. And they might be, for me, they're a little hard to see, so it might be hard for you. Here's the combined forms over here. And let me just kind of make that one larger so you can see it. Sine of A plus or minus B equals sine of A cosine of B plus or minus cosine of A sine of B. Cosine of A plus or minus B equals cosine of A cosine of B minus plus sine of A cosine of B. Wait, what's a minus plus? Well, when we have a plus or minus, usually if you do the plus, it's the plus over here. If you do the minus here, it's a minus there. With the plus, with the minus plus, if I do A plus B, I should do a minus, right? If you look down here, cosine A plus B was minus the other part. So if I'm doing cosine of the angle difference, it'd be A minus B, which means I'm going to add between them. That's how it works. And you can see how sine has the plus minus, cosine has a minus plus. In tangent, there's a plus minus there and a minus plus there, which just kind of helps reinforce how tangent's defined. So here's how we could actually use it. Now, we're not going to do tons of these in class or in your practice. It might show up a little bit, but I'm not going to do a whole lot with this right now. Normally I would, because this is the coolest thing in the world and I love it, but time, it's COVID, we're going to move on. So I can evaluate this exactly by using the angle sum and difference. What I have to do is just come up with two angles that add or subtract to 7 pi over 12. And after playing around, I came up with sine of pi over 4 and pi over 3. To evaluate that exactly, I split it up via my rule and evaluate it and simplify. That's how we can do that. It's pretty sweet. So to finish up, we'll do this in class. No, let's do it right now. And then you can just watch and we can spend time talking. So suppose alpha is an angle in quadrant 2 and beta is an angle in quadrant 3, such that sine of alpha is 4/5 and cosine of beta is -3/4. No question has been posed yet. What we're going to do, let's draw a picture to see what's going on. There's for alpha. It's in quadrant 2. Notice how this. And again, for sine, it said +4/5. So sine of alpha needed to be 4 over 5. Then I needed to solve for this other side, which gives me 3, -3. And it's -3 because in quadrant 2, cosine's negative. And then beta's in quadrant 3. So sine and cosine are going to be negative. And I know cosine of beta is -3/4. So I get -3 for the radius. The hypotenuse is always positive. And then using Pythagorean theorem, 16 minus 9 gives me 7. Square root of that gives me -square root of 7. All right, I made the triangles. Now I can do stuff. What's cosine of alpha? What's sine of beta? Well, the triangle's already made. That's fairly straightforward to do. The triangle's also made here. It's already pretty straightforward to do. What we can do now, we don't know the exact angles, but we have the triangles to go along with them. We could expand something out like sine of alpha minus beta, right? We could do that. By the way, there's a hidden slide here that will show you my work to finish off this problem. All right. I'm not doing it right now to try to keep this video short. All right, that's all I have for today. We're going to spend the rest of the time working on 3.2.2 or 8.3.2.